What's up, people? Welcome to the session. Welcome to Vedantu 9th and 10th English channel. How are you guys doing? All awesome? Can you guys all hear me and see me clearly? Let me just check if everything is all right. Okay, just give me a second. All right. Yes. Hello. Hello. Can you guys hear me? Hello. All right. I'm still not able to see the chat. Hold on for 1 second, people. I think there's some sort of issue. Hold on. Just close it. Noise. Click, click, click. All right. Yes, finally. What's up, guys? What's up? Yes, now I can see your chats now. What's up, people? Hi, Lohit. What's up? Hi, Lohita. Sorry. Hi, Kanishka. What's up? Hi, Jaideep. Hi-fi. Hi-fi. How are you guys doing? All awesome. How is your Christmas Day celebrations? Yes, I'm great, Satyam. I'm great. How are you guys doing? All awesome. How was your Christmas Day celebration? What are your plans for your New Year's, by the way? How many of you guys are stuck at home? How many of you guys want to go out but still are stuck at home? By the way, in Bangalore, they have started a night curfew. So from now on till and for the next 10 days, we are not supposed to get out from 10 p.m. to 5 p.m. or 6 p.m. I'm not sure, 6 a.m. in the morning. Stuck at home, no? Same. We can't go out also. So the government has made a rule not to go out. So even if we want to go out, we can't. No, I'm from Bangalore. I'm good, Jaini. How are you doing? Welcome, guys. Welcome. I hope all of you guys are doing great and taking care of yourselves, staying safe. Guys, you know that the number of Omicron cases, the number of, COVID cases are increasing day by day. So please take care of yourselves, right? And make sure you protect yourself as well as your family, because you're not protecting yourself, you're also protecting the people with you. So try to keep yourself safe. Try not to go out as much as possible. I know you have schools and stuff, but even in schools, please keep sanitizing your hands. You're putting everyone at risk while you do so, right? So please keep yourself safe and, keep sanitizing your hands and make sure that you wear mask at every point. And every time you walk out of your house, do not forget to wear your masks. We have to start taking precautionary steps right now itself, so that we don't reach that peak when it comes to the third wave. All right. Oh my God, Shanvi. Wow. Good to see that such honesty. Yes, I don't Kannada. Welcome, guys. Welcome. I'm doing great, guys. Thanks a lot for asking. Welcome to the session. Welcome to Vedantu 9th and 10th English channel. Before we get started, make sure you subscribe to the channel if you don't want next 3 years of bad luck. Yes. And make sure you hit the like button also if you don't want 5 years of bad luck. All right. So people, what we're going to do in today's session is not resistance in series and parallel. Sorry. So guys, in today's session, we are basically going to talk about heating effect of electric current. That's what we're going to talk about. We're going to talk about heating effect of electric current. What exactly is heating effect of electric current? How does it matter? What are the factors it depends on? How to calculate heating effect of electric current? It's going to be a very light and breezy session. It's not going to be too much content heavy. So make sure you stay till the end. Attempt all the quizzes, and more importantly, pay attention to whatever I'm about to say. Okay, guys? And by the way, Spider-Man No Way Home is out. So this is a tribute to No Way Home. Unfortunately, I can't really see it. So I thought, why not we start this session also with a riddle. So this is the riddle for today. The riddle is, what do you call an electrician who has detective quality? Remember my last riddle? This is one level above that. Adakam melee. All right. So what do you call an electrician who has detective qualities? Anyone? Rishi, it was negative. Thank God it was negative. Abhishek sir is also safe and sound. He'll also, I think from today, you'll see him coming live again. So Abhishek sir is also good. All right. Don't worry about him. He's all fine now. Hi, Pratismita. What's up? Good afternoon. Anyone? Nobody? Arre. Okay, what are you guys busy Googling or what? Such a simple riddle. No idea. Get idea. Oh, by the way, it's called as Vodafone now. Get Vodafone then. Okay, anyone? No, bouncer. All right. Okay, give up. No, give up. I'll give the answer. Such silly riddles. My God, giving up so easily. Shame, puppy, shame. Okay, the answer for this, guys. What do you call an electrician who has detective qualities? The answer is Sherlock Holmes. Getting it? Sherlock Holmes. Like Ohm's law. Getting it? Next level. I'm telling you, next level. This is related to the topic we're going to do today. Getting it? Next level. I know. It's Sherlock Holmes, not Holmes. Holmes. Holmes law Holmes. I know, guys. I know. My riddles are next level. I know. We can talk about it later. We can argue how awesome my riddles are later. But let's get started with today's topic. So, anyways, guys, welcome to the session once again. So, like I told you guys, today we're going to talk about the heating effect of electric current. It's going to be a very simple topic. Don't worry about it. Aram so you can get to know it. It's a very simple topic. Few formulas you need to remember here and there. That's pretty much it, right? But before that, guys, I know that you guys have been waiting for Menti meters. So let's quickly hop on a Menti first. We'll do the first couple of questions from the previous session. If you have not attended it, please make sure you check the video out of that. It's I think I came live last week for this particular topic, that is series and parallel connection. So make sure you check that out as well. All right. So the code for today's Menti is this, people: 577245536. Hop into Menti quickly so that we can get these questions done. And after that is done, we'll go to the topic, and then again we'll have another Menti after the topic is done. All right, let's go. Thank you. Yes. I know Kannada. I mean, I've been here for not almost, my entire life I've been in Bangalore, so obviously I should know Kannada. Otherwise I'll get beaten up. I have a lot of Kannadiga friends, so yeah. In fact, my partner is also Kannadiga, so obviously I should know though. Otherwise, she'll kick me out of the house. So yes, I know Kannada. All right, but I don't know to read though. I'm very bad at reading stuff. Like I can read this thing, Majestic Bus and all. Like the bus board I can read, but I can't read beyond that. That Uttaksha and all I can't. Louder, okay, guys. Are you not able to hear me clearly? I'll just try to increase my volume a little. I hope it's fine now. Yeah. Yes. Quickly, Ishwari, hop on a Menti, guys. The code is 577245536. All right. Let's go. Had cake for Christmas. Very nice, Jenny. What did I have? I had nothing. My mom was like, we have to do some puja and all. So she did not let me buy chicken also. It was a dry day. I just had some vegetarian grass. Vegetarian grass is what I had on Christmas Eve. Sad life. I didn't buy, I didn't want to buy a cake because it's like too many calories and all. So, all right, quickly, people, whoever is there, quickly join the Menti meter as well. The code is 577245536. All right, I'll get started then. I believe pretty much all of you guys are here. Whoever has not joined the quiz yet, please join the Menti meter. It's better than seeing my face. You can actually take part in the quiz and see how much of the subject you know. All right, so people, 3 questions. That's all I have for you guys for the first quiz time. Here's the first one. When two identical resistors of resistance 10 ohms are connected in parallel, the resultant resistance is dash ohms. If you have two resistors, each of 10 ohms, if you were to connect them in parallel, how much would be the equivalent resistance or the resultant resistance? Options are 20 ohms, 10 ohms, 5 ohms, or 16 ohms. Let's go, guys. Come on. Quickly. Misclick. It's okay, Sai Prerna. It's all right. One question. No, make it up in the next one. All right. Quickly, guys. 14 seconds. That's all you have. I know I should have given you guys more time for this question, but unfortunately, I didn't see the timer anywhere. Really sorry for that. But anyways, 4 more seconds. Try your best to answer this in the given time. I know 45 seconds is very less, but still, let's see how many of you guys got it right. Still rotating. Yes, 16. That is a good number, guys. That is a really good start. Absolutely fantastic. I was expecting a lot less since it's a numerical, but still 70% of the class. That is a really good number. Proud of you guys. Proud of you. So how do you do this question? It's a very simple question, guys. You have two resistors which are connected in parallel. So if you want to calculate the equivalent resistance, it is nothing but 1 by R1 plus 1 by R2. That is the formula to calculate. So substitute the values: 1 by 10 plus 1 by 10. That's nothing but 2 by 10. That is nothing but 1 by R equivalent. So what is R equivalent? R equivalent is equal to 10 by 2, which is nothing but 5 ohms. Simple as that. Super easy question. I don't think you don't need 45 seconds to do this, but if you guys are worse than me in math, then yes, you might require a little bit more time. Yes, Sanskar J, finally AKR sir is back. Nevin, then it's Jaydeep, Pankaj, Tannu, Anushri, Krista, followed by Pratismita, then it's Shanvi, Heloda, and then Rutuja as well. Congratulations, well done. Okay, 2 more questions. for the first quiz time. Here's the second one. I hope you guys are ready for this one. It's going to be a lot more easier than the first one. I don't think it's a difficult numerical. So here we go. The second question is, two devices are connected between 2 points, say A and B, in parallel. The physical quantity that will remain the same between the 2 points is what? Current would remain same in parallel connection, voltage remains same, the resistance remains same, or none of these. Let's go. 15 seconds. Well done, guys. Well done. Absolutely, absolutely. All right, quickly, guys, quickly. Whoever hasn't answered yet, quickly answer the question. And whoever's joined in just now, please join the Mentimeter as well. The code for today is 577245536. Let's go. Super awesome, guys. Super awesome. Alright, 15 of you guys got the right answer. That is not bad again, people. Fantastic job. How much? Okay, that's about 68%. That's a really good number. But yes, guys, for all those who are confused about this still, in parallel connection, please remember that the voltage remains same, but the current gets distributed. In series connection, however, the current remains same and the voltage gets distributed. So please do not forget this. I've already made a video on this topic in the last last week that we had. So make sure you check that out because you'll understand everything related to this topic that you're confused about, right? So don't worry about it. Aram se go through the video, and once you're done with watching the video, read your NCRT also. It'll take hardly 10-15 minutes. Once you read your NCRT, you'll never forget that concept again. All right. Once again, Sanskar was the fastest to answer, followed by Nevin. Then it's Tanu, Shanvi, Jaydeep, Pankaj, Loki. Then it's Ritisha, Jenny, and Uttam. Uttam ji, what's up? How are you doing? Welcome. All right, guys, last and the final question for the first quiz time. Once we are done with this, we'll go to the topic first and then we'll have another Mentimeter right after that. All right, the last question for today. Here we go. The first quiz time. Sorry. All right, here's the question. Two resistors of resistance 2 and 4 when connected to a battery will have same current flowing through them when they are connected in parallel, same current flowing through them when they are connected in series, same potential difference when they are connected in series, or different potential difference when they are connected in parallel. I have two resistors, one is of 2 ohms and the other is of 4 ohms. What would happen if I were to connect them either of the ways? That is, whether I was to connect them in series or in parallel, which of these would, which would be right or would be accurate in this particular scenario? All right, awesome. My God, people, that is absolutely fantastic. Fantastico, 88%. That is fabulous, guys. Hardly any of you guys made mistakes in that question. That is super awesome. High five, guys. High five. My good. Speed out of you guys. Absolutely correct, guys. It is nothing but the current, because in series connection, current remains same and voltage is different. And in parallel connection, the current is distributed, whereas the voltage is going to be the same. Super awesome. Proud of you guys. Oh, awesome. My God. Anyways, so here's your final leaderboard for today. Unfortunately, Jaydeep got the wrong answer. Jaydeep ji. Even the toughest question, you got it right, but unfortunately. Hey, Sanskar, congratulations. Yes, buddy. Awesomely well done. Second is Shanvi. Third is Nevin. Then it's Tanuj, I believe. Then I am not able to see the name. And then it's Loki, followed by Jenny. Then it's Uttam and Jaydeep. Congratulations. Well done. So that is the end of the first quiz time. Now, guys, we'll get into the topic first because we have to study as well. So once we're done with the topic, then we will come back to the Mentimeter once again. All right, people. So once again, quickly give me a oh yeah in the chat box. Like give me a elongated yeah. Yeah. So we can get started. I want that Josh. I want to see that Josh. That's going to give me some energy. Quickly. So what about ICSE? Krishna, the video for ICSE is going to come out on Friday. All right, it's for sound. I've divided into two separate one-shot series. So sound one-shot series, part 1 would be coming out on this Friday. All right. Yeah, that's the spirit. I like it. All right. So let's get started. Everyone, listen up carefully. I'm not going to be, I'm not going to bother you guys too much. So just relax your brains a little and just focus on what I'm about to say. Trust me, if you would listen carefully, you'll understand this concept very clearly. You won't have to, go through looking for a number of videos after this. So listen carefully. First thing, guys, you need to understand that heating effect of electric current is something which happens in our day-to-day life. For example, I'm pretty sure you wake up in your morning, like, when you used to go to your schools and all, right? If your shirt is wrinkled up, your mom would be like, take up, just iron it before you wear it, right? So this iron box basically works on the principle of heating effect of electric current. Not only that, for example, if you talk about room heaters also work on the function of they work on heating effect of electric current. Even electric kettles where you make your tea, even in that you're actually using the same concept of heating effect of electric current. You have n number of examples like this. The hair straighteners that especially girls love, the water heaters, to your room heaters, to those induction cookers and all that you have, all of these work on the principle of heating effect of electric current. So you need to understand what is this heating effect of electric current and what is the principle behind it. That is the only reason why CBSE has put this into your syllabus. What exactly is the reason why this happens? And how does it really work? That is what we're going to understand today. But before that, guys, let me tell you one more thing. It's not that heating effect is always desirable. In some cases, for example, let's say you put your phone to charge, all right, and you put it on for, let's say, 1 hour or 2 hours, and you forget for a couple of hours, all right? So let's say that you put in in the middle of the night, you put it to charge, and you wake up in the morning the next day. Now, if you touch your adapter at that time, you see that the adapter will be actually hot. Right, and it goes with, especially when it comes to your laptop chargers, they get hot really fast, and the temperature is also much more, it's much more hotter compared to your phone chargers. So here, what's happening is that there is a loss of heat happening. Now, your intention when you connect the charger of your phone to your socket is not to produce heat. Your intention is not to heat up the room, but it still happens. Now, there it is a wastage. There what's happening is that electrical energy is getting converted into heat energy. But again, the question is, why does this happen? And why only heat? Why not something else? Why couldn't it be tidal energy? Why couldn't it be some other form of energy? Why especially heat? So listen carefully, guys. Now, in the last session, you've already studied about resistance. I'm hoping everyone here knows what resistance is, right? We've already talked about it in the previous sessions. I think that was the third session that we did. So we have already talked about the factors affecting resistance. What is resistance? So if you're confused about this, again, go back to that video. You'll understand everything. Now, what is resistance is nothing but, guys, the obstruction offered to the flow of current. When you connect a battery, when the electrons are flowing from one end to the other, what happens is that they will collide with other electrons or other ions. And every time they collide, what is happening is that they're losing momentum. Along with momentum, what is happening is that they are also losing energy. Now listen carefully. Here, if I connect, let's say this is a wire, right? So the electrons are freely flowing. Once I connect the battery, what happens is that the battery is doing some work to push the electrons from the negative terminal to the positive terminal. It is doing some work. The battery is the one that is actually doing the work to push these electrons from one end to the other end for it to complete one circuit. Now, while it is doing so, what happens is that they will collide with other electrons and other ions. And every time it collides, what happens is, guys, it is losing electrical energy. Whatever is the work done by this battery, it is losing some amount of that energy while it is colliding with these other electrons or other ions. And this collision is what is leading to the production of heat energy. This collision is what is leading to release of energy in the form of heat. Now, there's a small little formula that I want you guys to remember when it comes to heating effect of electric current, because again, you'll have lots of numericals based on this particular topic. So just to give you guys an idea of how to approach these kind of questions. Now, guys, we know that voltage is nothing but, or potential difference is nothing but work done per unit charge. So from this equation, I can say that work done is equal to a potential difference into charge. Simple. So this is what I have. Now, what I'm going to do, guys, see, the thing is that whatever is the work done by the battery, that work done is done to do what? It is done to give energy to the electrons. So whatever work is done by the battery, what is it doing? It is providing energy to the electron so that it can move throughout the circuit. So what is happening is that the work done by the battery is equal to the energy gained by the electrons. Are you able to understand this, guys? Are you able to, the work done by the battery, what is the work of the battery? The work of the battery is to provide energy to the electrons so that they can complete that circuit. That is the function of the battery. That is the work of the battery. So I can say that this work done is equal to energy, which is equal to potential difference into charge. Simple. Able to understand this, guys? Hi Deepanji, what's up? Hi Priyanshu. Yes, guys, is it clear so far? Is there any sort of confusion so far? Able to understand, or is it going over your head? What is happening? Please tell me. All good? Pakka Uttamji, 100%. Or everyone else, da? Pakka Jayani, 100%. No? I want to ask yes or no from every one of you guys. Quickly in the chat box. I'm waiting for you guys to answer whether you have understood. Pakka, no? All right, yes, okay. Understood? No? All right. So that is what is done by the battery over here. So this, I can say that, guys, this energy spent on the electrons is equal to work done by the battery, which is equal to potential difference into the charge. Now, when it is, I told you, when the electrons are flowing, what will happen is that they will collide with the other electrons or other ions, and they will end up losing some energy. And this loss of energy is what is in the form of heat. For example, guys, another example that I can give you, a very real-time example. Okay, if you've ever been on a bike, guys, if you've ever been on a bike, right? Now, if you were to ride your bike for some time, first let's say if you ride it for 10 minutes or 20 minutes, what about the engine? Just think about the engine for a second. Right? Imagine it's a Royal Enfield. Will the engine be hot or will it be cold? Will the engine be hot or will it be cold? If you talk about Royal Enfield or any bike for that matter, if you were to ride it for some time and stop the bike for a second, will the engine feel hot or cold? Absolutely it's going to be hot. Now my question is this: do you turn on the engines of your bike to heat up the surrounding? Do you turn on the engines of your bike to heat up the surrounding? Is that the function of the engine over there? Is that the function? Obviously not, right? You don't care about that. But still what is happening is that there is loss happening. There is loss. So what's happening is that when the petrol is burnt, or when the fuel is being burnt, some amount of energy is lost as heat. And that's what's happening over here also. There is always loss, guys. There is always loss in nature. So here also, when these electrons are colliding, there is some amount of loss. And that loss in energy is in the form of heat. That is what is heating effect of electric current. So like I told you before, guys, whatever is the work done by the battery, that is equal to the energy gained by the charges, because whatever is the work done by the battery, that is done on these charges to move from one point to another. So in other words, they're giving energy to these electrons so they can flow throughout the entire circuit. Now, more the energy that the battery gives, there'll be more number of collisions. Right? Common sense. No, see, when you're giving more and more energy to these electrons, as they're flowing, there'll be more and more number of collisions. So that means that there'll be equal amount of energy being lost as heat as well. So I can say that work done by battery is equal to energy gained by charge, which is also equal to energy lost as heat. Because as the electrons are flowing, there'll be collisions, and these collisions will eventually will get converted to heat. That electrical energy gets converted to heat energy. So whatever is the energy gained by charge, that is also equal to the energy lost as heat as well. So I can say that, guys, this is equal to H, where H is nothing but the heat energy lost, or the heat energy that is produced during this collision. So I can say, guys, H is equal to V into Q. Now what I'm going to do is very simple, right? Listen carefully. What I'm going to do is I am going to multiply and divide by T. Multiply and divide by T. All right, time. So H is equal to V into Q by T into T. Now, again, guys, here the value of TT does not change, right? For example, if I want to remove this, the value does not change. The value is still equal to 1 itself. So what I'm going to do is, guys, I'm just basically trying to convert this charge into current. That is all I'm trying to do. So we know that, guys, from the previous equations, we know that current is nothing but rate of flow of charge. So I can write this equation as H is equal to V into I into T. This, my friends, is the basic formula to calculate heat energy produced in a circuit. One of the most basic formulas. H is equal to VIT. Alright, this is the most basic formula. Now, there are different versions to these formulas. What do I mean by versions? Because, guys, according to Ohm's law, we know that V is equal to IR. So if I were to substitute the values over here, for example, one of the equations can be H is equal to, instead of V, I can substitute as IR. So I can write it as I square RT. This is one such formula. Another equation can be, I is equal to V by R. So instead of I can substitute V by R. So the formula can become V square by RT. This is yet another formula. So all of these are basically the same, it helps you to calculate the heat energy produced inside the circuit. However, when you talk about these formulas that I just told you about, all these different formulas, the one that you need to remember the most is the first one, that is this one, that is H is equal to I square RT. Why should you remember this, guys? This is what is called as Joule's law of heating. This is what is called as Joule's law of heating, which basically states that the amount of heat energy produced in a circuit is directly proportional to the square of the current flowing through the circuit. The amount of heat energy produced in a circuit is directly proportional to the resistance of that circuit, and the amount of heat energy produced in the circuit is directly proportional to the time for which the current is flowing through the circuit. More the current, more the heat energy. More the resistance, more the heat energy. More the amount of time the current is flowing through the circuit, that is more the time you connect the battery and you turn it on, more would be the heat energy as well. So this is what is called as Joule's law of heating. That is, the heat energy produced in the conductor is directly proportional to the square of the current, it is directly proportional to the resistance, and it is also directly proportional to the time for which the current is flowing through the circuit. Alright, guys, is that clear? Is there any doubts that you'd like to ask me, people? So that was pretty much it. That is Joule's law of heating. That is heating effect of electric current. We are done in 10 minutes, I believe 10-15 minutes. That's pretty much it. So just to conclude everything, guys, just to put everything into perspective, what we learned today is very simple. What we learned is that, see guys, once again, I'm just going to write it down. So pay attention. Work done by the battery is equal to V into Q. This is the basic formula, right? Because the potential difference is nothing but work done by charge. That's how we got it. Now this is equal to the energy gained by the charge. This is equal to the heat energy lost, or the amount of heat energy produced in the circuit. So I can say that H is equal to V into Q. Divide and multiply by T. So what will you get? This Q by T is nothing but I, that is nothing but current. So you'll get the formula as H is equal to VIT. Now this is one of the most basic formulas. This is the first formula of heating effect of electric current. The second formula is, in place of V, we are going to substitute IR. So the formula becomes H is equal to I square RT. This is known as Joule's law of heating. This is what is called as Joule's law of heating. We also have the third formula, which is nothing but H is equal to V square by R into T. That's it. That's all, guys. That's it. Khel khatam, dukaan band. Is it clear? Sir, do we use H as heating effect? Yes. H stands for heat energy produced or heating effect of electric current. All right. H is nothing but heat energy produced in the circuit or heating effect of electric current. However you want to take it as. So does that mean that in some cases like charges, heat energy is getting wasted? Yes, absolutely, Jani. Absolutely, there is a lot of wastage happening. See, for example, again, when you talk about electric charges, or especially the chargers that you have, the phone chargers or your laptop chargers, your intention is not to produce heat. Now the thing is, it's not always the case. For example, an incandescent bulb, that is the bulb in which you have a filament, right? In that, you need the resistance to produce produce the heat, so that it produce the light, right? So over there it is a necessity. But here in these kind of examples, it is not needed, but it still happens without your control because of the resistance, because of the current, and because of the time for which the current is flowing through the circuit. All right. So please remember this one very important formula. In most cases, you'd be using the second formula, that is H is equal to I square RT, that is Joule's law of heating. So please do remember all these formulas. To be honest, you have to remember all these formulas, but this is very, very important. All of these are important, equally important, but that is a little bit more important, like, maybe 10% a little bit more important than the others, because they might ask you what is Joule's law of heating. They might ask you to state the statement and write down the formula. So please do remember that. All right. Okay. Yes. Sort of. We'll have Menti. Sir, in third formula, resistance is inversely proportional to heat. See, that is a good question. Now the thing is that, see, if it all depends on what is given. For example, if current is constant, then you can say that H is directly proportional to resistance. If current is constant, all right, that is what. If current I is constant, then you can say that H is proportional to R. If voltage is constant, that is the potential difference is constant, in that case, H is inversely proportional to R. So it depends on what you're taking or what is given in the question. So you have to pay attention to what are the details given in the question. Have they mentioned the current? Have they given the voltage? So accordingly, you have to choose the equations. You have to deliberately figure out what is given in the question and then go with the correct equation according to that. All right, it depends on what is given. So if current is constant, you have to take you can say that heat energy produces directly proportional to resistance. And if voltage is constant, you can say that heat energy is produced is inversely proportional to resistance. Depends on that. All right. That is the funda behind it. All right. Okay. So people, I believe that it's time for the Menti meter. But before we go to the Menti, guys, it's Christmas time and it's New Year. It's going to be New Year pretty soon. So keeping that in mind, people, we have an amazing opportunity for you guys to prepare, to kickstart your preparations for your term 2 examinations with Vedantu on your corner to help you guys, to guide you guys in the right manner. Just to give you a quick hint about what Vedantu is, how are the classes going to happen in Vedantu, and whether you should take it or not in the first place. Let me tell you that first, guys. First of all, people, this is what the platform looks like, right? If you log into www.vedantu.com, this is what it looks like. So here, people, you can see all of the sessions that you're going to be taking or you have on that particular day, or for the entire month, or for the entire year as well. In fact, even if you miss out a session, you don't have to worry, because you'll have the past sessions as well. So if you just click on the past option, you can see all of the sessions that you already attended or you missed out due to some reason. So even if you miss out on a session, you don't have to worry about it, because you can always watch the replay, just like how it is on YouTube. You can always watch the replay and get your doubts solved right there and then. Now let me tell you what happens inside a session, right? Because that is also important. First thing, guys, we tend to have a lot of fun during the sessions, right? We try to, at least I try to crack all sorts of lame jokes, like what happened in the start. So we tend to start off the session with a riddle, maybe quote, something like that, to kickstart that brain of yours, so that you're focused on that particular topic. To keep the class interactive, we have something called as hotspots. So hotspots are nothing but you have 4 options. You can choose A, B, C or D, whichever you feel is right. Not only that, just like how you have Mentimeter, we also have our own quiz in the platform, in our very own platform. We have our own quiz where you can actually take part in the quiz, and accordingly you'll have leaderboards, fastest fingers list, where you can see how fast you have answered and whether you've answered the correct answered it correctly or not. You will also have stars during the session. Now the thing is, guys, in Mentimeter, it's very difficult to recognize everyone, because the problem is that some of you guys will have your names on the leaderboards, but most of you guys might not be there due to certain reasons. You might not be able to come up on the leaderboard. But here, guys, even if you don't get on the leaderboard, it's all right, because you get stars for every right answer that you get. Even those stars are also considered. So that means that everyone gets a chance. You don't have to worry about whether you're fast or no, or maybe your internet is slow. You don't have to worry about all of that, because you'll still be getting the recognition that you guys deserve. And like I told you, you'll also have leaderboards, and that will show you an accumulation of how well you have done in comparison to your friends inside that particular session. And not only that, guys, we have doles, we have drum rolls, all sorts of amazing stuff to keep the class interactive and interesting. That is what we are trying to strive for. We're doing our very best to make sure that you guys understand the concept, but at the same time you also have fun with the process of studying. And not only that, people, unlike YouTube, you can actually get yourself unmuted and even uncapped. That means that if you have a doubt, you can just ask the teacher to unmute you, and the teacher and you can actually basically have a conversation inside the class itself at any point in time. Doesn't matter where it is, you can always get your doubt solved that way also. So again, here that is not a possibility on YouTube. You just have to type it, and sometimes I miss out your chats. But here, guys, you don't have to worry about it, because not only this, in every session, you will also have someone called as a class teacher. I don't know if you can see this, guys. There is a small column over here at the bottom where I've put my, I've put my arrow, the arrow. You can see that there's this thing called as doubts column. Now, in this doubts panel, right, you'll have someone called as a class teacher who themselves have more than 5+ years of experience, who will be there throughout the entire session to clear your doubts. Yeah, they'll be there to clear your doubts alone. So you don't have to worry about ever missing out on your doubts, because for sure your doubts will be cleared inside the class itself, either by the class teacher by getting unmuted, or with the help of the class teachers, or with the help of the master teacher. One way or another, your doubts are going to be cleared. And apart from these, while you're studying while you're doing your self-study, if you feel like you have a doubt, you can even download the Vedantu's doubt app. Send a picture, click a photo and send it, and you'll get your doubts cleared by experts from there also. So your doubts will never go unanswered. That's what I'm trying to tell you. And just to give you a hint, guys, just to give you a small, a parameter, like this is one of the sessions that I took. Now, in this particular session, there were about 159 doubts that was asked. You can see the total number of doubts asked were 159. Out of that 159 doubts was solved inside the class itself, and about 29 doubts were broadcasted inside the class, which means that everyone could see those 29 messages. And like I told you, your doubts will never go unanswered. So you'll always have the support of the class teachers and the master teacher to ensure that all of your doubts are cleared. And if in case you want to download the notes, all you have to do is this, guys, go to the past session, click on this notes wala option, and your entire PDF will be downloaded, and you can basically go through this PDF whenever you want at your own comfort. If you feel like you need to go back to the concept one more time, all you have to do is click on that. The entire PDF will be downloaded, and everything, the handwritten notes, whatever the teacher has written on the board, everything would be there, and you can go through that whenever you want, right, guys? And not only that, people, you also have something called as micro courses, which means that along with the long-term sessions, you can even choose a particular topic. For example, let's say that you're finding Ohm's law difficult, so you'll have micro courses of those particular topics, and you can join those courses and get your doubts solved over there also. You will have numericals classes just like that. You will have concept-based questions in these kind of micro courses. Not only that, people, in these micro courses, we also tend to give you guys a little extra. That is, you will have leadership classes, you'll have entrepreneurship classes, you will have class on public speaking, on debate competitions. You will have experts coming in and talking on the platform about how to improve yourself at this very young age. True, to be honest, I wish I had this kind of an opportunity, because I'm a very horrible, terrible public speaker. But yes, you guys are getting an opportunity to improve yourself, not only with respect to your education, that is with respect to your CBSE, how well you're doing in your boards, but you're also getting an all-round development over here. Now, how do you join? Very simple, guys. How do you take part in this? Very, very simple. So this is the session that is going on right now, right? Yes. So all you have to do is this, people, go to the description of this video. All right. First of all, subscribe to the channel and hit that like button. If I can do it, you can also do it. All right. So what you do is this, guys, go to CBSE Term 2 full syllabus. Very simple. Click on this link. It'll take you to the Vedantu's webpage. Now, listen carefully, because here is the cherry on top of the ice cream, or the cherry on top of the sundae. Here's the thing. What is happening to my internet? All right, just give me a second, guys. I don't know, for some reason, my internet is very, very fast today. Just give me a second. Let me see if I can open it up again. It was working fine all this while. All of a sudden, I know what happened. Okay. All right. Internet. Thank you for naak katwane ke liye. Thank you. Very much appreciated. 1 second. Let me just check my speed. My internet is very, very fast today for some reason. I don't know why. I mean, for the past couple of weeks, I've been having a lot of troubles with my internet. Wait. Thank you, Perk. All right. Internet speed is apparently good. Okay, just give me a second. Just give me a second. 1 sec. What's happening? All right. Amazing. Thank you. Thank you, Internet G. Thank you. Wait, what's happening? All right. Okay, my internet is actually pretty slow. There's a dip. All right. 1 sec, guys. 1 sec. Hold on now. What is happening to my internet? Hey. Shame, puppy shame. Finally. All right. Finally. All right. Just give me a second, guys. Just give me a second because here's the thing. Here's the thing, guys. For New Year, and because it's Christmas and New Year, you are actually getting an amazing opportunity right now. All this while, I'm pretty sure a lot of you guys were hesitant to join because of the money part of it. Because, some of you guys feel like it's too expensive. So here's the thing, guys. Like I just told you, everything included, everything that I just talked about right now, you're getting it. Forget about the long-term course right now, right? I want you guys to focus on the 1 month trial program. 15 days trial for just 650 rupees if you use my coupon code today, that is AME Pro. AME Pro. If you use my coupon code AME Pro, you'll be getting a flat 50% discount. That means that from 1,300 rupees, it'll come down to 650 rupees. And here's the catch. This 15-day trial will actually be increased to 30 days. For 30 days, all 6 subjects, physics, chemistry, bio, math, English, social science, all 6 subjects, all of the features that I talked about, including micro course, everything included, for just 650 rupees, you will not get an opportunity like this to enroll yourself in and to kickstart your journey for your term 2 preparations. Trust me on that. That means that per subject, you're barely paying 100 rupees, 100 change, 100, maybe 105 rupees, 103 rupees. That is what you're paying. Maybe 110 rupees, around 110 rupees is what you're paying per subject for the whole month. That is not for 15 days. That 15 days will be extended to 30 days. So for whole 30 days, if you use my coupon code AME Pro, this is my coupon code AME Pro, you'll be getting a flat 50% discount and the price just drops down to 650 rupees. Now, if you want to go for the long term, money is not a problem. And if you're going to go for the long term, the whole thing that is until the end of your term 2 syllabus, then you can go for the whole thing that is, it'll be around 10,000 rupees. Again, that is after discount, 50% discount up to 2,000 rupees is what you're getting. So here what's going to happen is that from 12,000 rupees, the price drops down to 10,000 rupees. So you're getting a flat 2,000 rupees discount over there. And again, you want to go for the long term, but still money is a problem. You don't have to worry about it because you can even choose the EMI option over here. So you'll have to pay around 1,667 rupees per month. Around 1,600 rupees per month is what you'll be paying. Again, for all 6 subjects with revision, with micro courses, with all of the other micro courses that I just talked about, every other, courses that are going on parallelly, and tests, assignments, everything included. This is what you're getting from it, guys. For a very, very, very nominal price, you're getting a lot. When I say a lot, I mean a lot. And we're constantly adding new stuff to it. But to be honest, guys, if you ask me, you should go with this one, the 1 month trial. See for yourself. See if it is something that works for you or not. Try the 15-day trial first. 15 days, like I told you, will be for 30 days. So try the 1 month trial first. It's around 650 rupees. I mean, pizzas cost more than that, right? So 650 rupees for 1 month of your education with the best of the best teachers. I don't think you'll get a better deal than that for all 6 subjects that too. So try it out. It's only, this offer is only valid till the 3rd. till the 3rd of Jan, that is until Monday. That is all. After that, again, it's going to go back to 1,300 rupees. Before it, again, why do you want to pay 1,300 rupees for the same price? For the same course, you're paying 1,300, whereas right now you'll be paying around 650 rupees. Again, half of it. So why would you want to pay later and pay double of it, right? So if you ask me, guys, this is a better chance right now to get into the course. If money was ever a problem, this is the best solution there is to it. All right. So anyways, guys, with that said, let us now get into the quiz questions because I know you've been waiting for it. So people, quickly join the Mentimeter. Sorry for that. Quickly. All right. So guys, everyone, quickly join the Mentimeter. The code is people 49953 Let's go. So can you teach English medium surprise class 7? Sure, Arjun. Sure. Why not? I'll come. Peekaboo. Surprise. I'll stand behind your English teacher and I'll go peekaboo. All right, quickly guys, quickly join the Mentimeter. This is the last quiz time for the topic for today. Whatever we do today, I'll be asking you questions based on that. All right. So quickly guys, whoever is in right now, please join the Mentimeter. There's no point in sitting there and watching the session. I would rather you guys to take part in the quiz and make mistakes and learn from those mistakes. All right. So let's go guys. Come on. Quickly guys. All right, I'll give you another 1 minute. Quickly now, whoever's there right now. I can see about 30 of you guys here, but only 18 of you guys have joined the Mentimeter. So you have to do this, people. Whoever is new, just go to www.menti.com. You can see there's no menti.com. This all you have to do is this. Enter this website, menti.com. Once you enter this website, they'll ask you for a code. The code for today is this. Enter this code 49953 All right, you can take part in the quiz and have fun in that. Done. All right, people. So I'm going to start the quiz then. I'm pretty much sure that every one of you guys are here. So I'm going to start the quiz in 3, 2, 1. 4 questions. What I have for you guys. So the first question is this: if the current passing through a heater is halved, then the heat produced in it will become h by 2, 2h, h by 4, or 4h. Sorry, if the current passing through a heater is halved, what will happen to the heat produced in it? Now, what I want you guys to do is, guys, use your Joule's law of heating over here and try to figure out what will happen to the amount of heat produced if I were to decrease the current by half. If the current value was 30 before, now it has become 15 amperes. If that is the case, what will happen to the heat energy produced in the circuit? Sorry. Hi Azam, what's up? How are you doing? Yes, quickly guys, quickly. Quickly, All right, 10 more seconds guys, 10 more seconds. All those who have not answered yet, jaldi karo ji. Ki kar rahe ho? Kiske liye wait kar rahe ho? Oh my god. I told you to use Joule's law of heating. Now, what is this, people? Shame, puppy, shame. 16 of you guys went with h by 2. Now, the thing is, guys, again, see, when, like I told you before, this is the most common formula associated with heating effect of electric current. That is Joule's law of heating. So please follow that. Please use your Joule's law of heating every single time. Please go with that. So here, people, if you use Joule's law of heating, H is equal to I square RT is the formula, which means that H is proportional to I square. If the new current value becomes I by 2, then what will be the value of heat energy produced then? I by 2 the whole square, no? So it will be H is proportional to I square by 4, which means that the new value of heat energy produced will be H by 4. It will be 4 times less than the original heat energy produced. I told you to use heat. I even gave you the hint also. Use Joule's law of heating. Please don't go with the first formula, H is equal to VIT. This formula is not that commonly used when you talk about heating effect of electric current. In majority of the cases, we will be using Joule's law of heating, which is H is equal to I square RT. That is what I told you. That is why I told you that is by far one of the most important formulas, especially in this chapter. That is the most commonly used formula. Even though you have a lot of other formulas, this is Joule's law of heating. You have to use that formula itself for figuring out the answer over here. All right. It's all right, Kutamji, it's all right. But 8 of you guys, how many? 30%. Whoever is at 8, no? For you guys and all of the others. Congratulations. 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 Be proud of you. All right, next question. Here's the leaderboard. I can see those 8 right now. Namdev, Sanskar, AK, Hi Yash. All right, Ashanvi, Tanu, Prem, and Prem. All right, Prem and Prem Kata. Then it's as Latin. Oh, Ibrahimovic. Then it's Zaid. Okay, Zaid Al Kushagra. Unfortunately, your name is there, but you did not get the right answer. All right, second question. Here is the second question, people. Go ahead. I know, Zaid. I know. Two wires with resistance R and 2R are connected in parallel. The ratio of heat generated in 2R and R is 1:3, 2:1, 1:4, or 4:1. Let me repeat the question. Two wires with resistance R and 2R are connected in parallel. They're connected in parallel. That is the key word here. The ratio of heat generated is in both of these resistors, that is 2R and R, is 1:3, 2:1, 1:4, or 4:1. Let's go, guys. Let's go. Let's go. Quickly, guys. Quickly. Let's go, people. And yes, do not forget to subscribe to the channel now, because we have some amazing content coming your way. Lots of things are in the pipeline at this point of time for your term 2 syllabus. So make sure you subscribe to the channel for all the 6 subjects we are taking up classes. So make sure you do not miss out on that, and hit the like button if you guys are enjoying the session so far. Otherwise, you're going to get 3 years of bad luck. I'm going to stick to this forever. 3 years of bad luck if you don't hit the like button. I'm telling you. 17 of you guys got the right answer. Just the opposite of that. Previously, it was just the opposite, but this time, well done, people. 55% of the class, that's half the class who got the right answer. Congratulations. Proud of you guys again. Okay, how do you do this question, guys? It's a very simple question, but yeah, see, guys, the key word is parallel. In parallel connection, we know that the voltage remains same. The potential difference remains same. So I have to use the formula H is equal to V square by R into T. Why? Because again, in parallel connection, the current gets distributed, right? That is why I'm using this. That is why I'm using the third equation that I mentioned before. That is H is equal to VIT is the basic formula. So what I'm doing is I'm substituting the value for I is equal to V by R. So the formula becomes V square by R into T. That's how I'm getting this. All right. Now, guys, for the first one, which I'll call it as H1, is equal to V square by R into T. H2 is equal to V square by 2R into T. So if we find out the ratio H2 by H1, that is equal to what? It'll be nothing but V square by R into T. Sorry, H1 by H2. Sorry, H1 by H2. That is H1 by H2. That is when you get the ratio. Sorry. So this will be H1 by H2. H1 by H2 is equal to V square by R into T whole divided by V square by 2R into T. So T gets cancelled, V square gets cancelled. This will go to the numerator. So what will you get? H1 by H2 is equal to 2R by R. R gets cancelled. So you can say that it is 2:1. That's how you get this question. 2:1. It's a longer calculation, I understand, but it's not that difficult, to be honest. Do you find this question? It should be 1:2. That is why I took the ratios H2 by H1. It should actually be 1:2, but here for some reason they've given it as 2:1. That is why I'm going with that. Or the question should have been R and 2R. Or the question should have been R into R, or it should have been 1:2. Unfortunately, they did not. There's a small error here because it's given other way around. But yeah, doesn't make much difference. But yeah, there is even then, it's still incorrect, but still. All right, so it should be 1:2. Right? It should be 1:2. All right, so the answer is going to be 1:2, guys. It's just that you need to understand this one basic concept, that is, in parallel connection, the voltage remains same, but the current is different. For that reason, you have to use this formula and not Joule's law of heating. So once you use this formula, it's just basic substitution, and you'll get the answer. All right, so that's it, people. Technically, yes, but in this case, we have to go with option number 2. All right. I know the question should have been R into R. That is what even I noticed. That's why even I had to change the value over there. But yeah, guys, sorry for that. It's a small error from our end. It's a small typo mistake. Please forgive us. All right. Please forgive us. Anyways, so here's your leaderboard, people. Namdev ji unfortunately chose the wrong answer. Shanvi also chose the wrong answer for this question because you went with 1:4, is it? It's alright, it's alright. Sanskar finally back on. Okay, again, fastest to answer. Second is Prem, then it's AK, Hi Yash, followed by Alisha, followed by Top Maregi. Alright. Alright, good to know, Alisha. Then it's Prem, Namdev, Zaid, Jace, Dawn. Alright, Shanvi, and Nevin. What interesting names, guys. Alisha top maregi. Let's see, Alisha ji. I'm waiting. Third question, guys. Third question. We have two more questions. That's it. This is the third question. So go ahead and answer this one now. The question is, an electric heater kept in vacuum is heated continuously by passing electric current. Its temperature will go on rising with time, will stop after some time as it loses heat to the surrounding by conduction. It'll rise for some time and then thereafter will start falling, will become constant after some time because of the loss of heat due to radiation. An electric heater is kept in a vacuum chamber, all right, is heat and it is heated continuously by passing electric current. What will happen to its temperature? Think, guys, it's a very common sense wala question. It's nothing, I mean, you don't have to calculate anything over here. It is just basic common sense about the basic understanding of the transfer of heat energy. You've already studied this in your lower grades in your 6th and 7th standard, so I'm hoping you guys know the answer. Oh my god, oh my god, this requires one amazing abbreviation. It's called as SSSSPS, which means shame, puppy shame. Because all right, because of this, let me tell you why. See, guys, for example, imagine I have a heater. Okay, let's say, okay, you guys have water heaters at home, no? You guys have water heaters. Some of you guys might have water heaters at home. Let's say you turn on the water heater and you forget to turn it off. Do you think the temperature will get so much that it'll burst? Or is it even possible that the temperature will keep on raising up? That is, will it go till 200, 300 degrees? Do you think it will happen? Do you think water will reach 200, 300 degrees if in case you turn on the heater and let it go and you forget it? I have a water heater at home which basically goes up to 90 degrees Celsius. Even if I turn it on the entire night, it will not go beyond 90 degrees. What I'm trying to say is this, guys, that there is a saturation limit. All right. So when even if you turn it on for a very long time, after some time the temperature will become nominal. It will become constant. And why does that become constant is because after it reaches a certain temperature, it will start to lose energy by radiation. Because, guys, it is vacuum. It's vacuum, and in vacuum there's nothing. It's basically nothing. See, for conduction to happen, you need physical contact. All right, there are three forms of heat transfer: conduction, convection, and radiation. Conduction, convection, and radiation. Now, for conduction to happen, there should be a physical matter. There should be actual contact between the object. So if I have a conductor, let's say this is my chamber, vacuum chamber, and my conductor is placed inside over here, there is no real contact with the surrounding. So conduction is not possible. Convection is also not possible because for convection to happen, convection happens in fluids. That is, either it has to be a liquid or it has to be gas. Now, it's a vacuum chamber, so there is no air or there is no water as well, which means that convection is also not possible. So the only way that heat energy will be lost will be in the form of radiation, and hence, people, option number D. It will lose energy in the form of radiation. Got it? Does it make sense? Hi Asha, what's up? Does it make sense, people? Are you guys able to understand? The temperature will not keep on rising up till 1000, 2000 degrees Celsius and all. It will not happen. After a certain temperature, it will stop, it'll stop going, it'll stop increasing, and it'll start to lose heat energy in the form of radiation. And if it's placed in air, both radiation and convection. All right. Is it clear, people? Understanding or still going over your head? Pakka? All right. So we will last and the final question. Last and the final question. Here we go. Thank you, Jason ji. Thank you. Last and the final question. Let's end it with a bang. All right. At least this one. Naak mat katwa dena. In English, please don't cut my nose off. All right. Okay. Sanskar, by the way, got the right answer. Ashlesha also got it right. Prem got it right. AK also got it right. Everyone else, Tanno also got it right, I guess. Jaydeep also, Azam also got it right. Prem also got it right. Namdev and Zaid, unfortunately not. All right. Last and the final question, guys. Here we go. The final question for today. Here it is. Let's go, guys. Let's go. The question is, the electric current passing through a metallic wire produces heat because of what? Collisions of conduction electrons with protons, collision of atoms of the metal with each other, the energy released in the ionization of the atoms of the metals, or collision of the conduction electrons with the atoms of the metallic wire. What is producing the heat energy? That is the question. In simple words, what leads to the production of heat energy? Yes? All right. Pakka? Think. All right. Once again, naak katwa dira. Okay, no. Thank God, people. Thank you. Yes. Finally, some good news. Yes, 70% of the class got the right answer. Exactly, people. See, think about it. Protons are present inside the nucleus. Do you think it is possible for an electron to enter into the nucleus and say hi to the protons? What do you think they are? What do you think they are? They're not your next door neighbors. Obviously not, right? So the only reason why it happens is because the electrons collide with the other atoms and other electrons. So option D, without any doubts. All right. Common sense, people. Common sense. All right. So, guys, that's pretty much it. That was the last and the final question for today. That is all. And here is your final leaderboard for today. But before that, again, guys, do not forget to like, share, subscribe to the channel, and make sure, share this video if you found this helpful, and if you think your friends can also find this helpful. All right. Anyways, guys, here is your final leaderboard, and that is pretty much it. Sanskarji is once again the winner for the second quiz time also. My God, Sanskar. What did you have for breakfast today? 2 plates of chawanprash or what? 3 plates of chawanprash. Chawanprash, like he puts chawanprash, bread and butter. He puts chawanprash on bread and all, and he eats it every day. He makes chapati also of chawanprash. Just and fry it and eat it. That's why look at that. Both the quiz times. My God, Sanskar. Smart boy. Then it's Ashlesha the second, who came in second though. Well done, Ashlesha. How did you stuck to your word? Then it's Prem, then it's Jaydeep, then it's AK, then it's Azam, then it's Nave, followed by Tanu, followed by Vatsala, followed by Leo Messi, joined after a second question. It's all right, Messi ji. It's all right. I know you're busy with practicing and all with PSGs. It's all right. All right. But anyways, guys, that's pretty much it for today's session. And once again, thanks a lot for joining. I hope you found it helpful. I hope this time that you spent with me was well spent. And do not forget to like, share, subscribe again. All right. Make sure that you do that, because otherwise, the next 5 years, bad luck. All right. COVID is not going to end if you don't like the video. If you want COVID to end and if you want to go back to school, hit that like button. All right, and subscribe to the channel. All right. So that's it, guys. That's pretty much it for today. Anything that you would like to ask me, any doubts that you have, you can please ask me right now, guys. We'll clear some doubts and then I will take leave now. Any doubts? Anything that you would like to ask me? Anything? Nothing? Something? Nothing? All good? Awesome. Yes, Radhi. Batman is back. Batman's got a cool hairstyle and all. No doubts, Jason. Good to know. If you have any doubts, guys, I'm good. How are you, Radhi? Hi, Shri. What's up? How are you doing? You're right on time for the next session. Yes. You're too early for the next session. The next session is going to happen tomorrow at 3 p.m. So, be there. Long time. No, I know, Radhi. I know. Hi, Samyakna. What's up? How are you doing? I know a little bit of Telugu, like Chadukopo, Bojnamainda. That's pretty much it. Oh, is it? You're in school and you... Oh, wow. Can we have a big round of applause for Adira? The kind of guts that it takes for, you're in your school, probably attending your class right now, and you're also watching session on YouTube. My God. Amazing. All right, so people, that's it. That is all. Is there anything else that you would like to ask me? I feel like there's nothing else then. All right, then, people, go have a wonderful evening. Enjoy yourself and take care. Stay safe. And again, please try not to go out. I know it's New Year's Eve and all is coming up, but still do not have any parties and all right now. It's not safe at all. Stay safe and let's not give way to third wave, right? Again, you'll be stuck at home, remember, and more importantly, your exams are also close and nearby, so do not take that risk and stay home, right guys? So that's it, people. That's it for today. Then GF, I'm married. GF, it seems. GF is for kids. So how come you carried laptop at school? I know, right? Probably training is going on. Oh my god, what training? What training are you talking about, Radhi? GF, it seems. I know I look like a young kid. I look like I'm forever 18, but still I'm married. I'm married. I'm not wearing the ring though, but I'm married. The biggest decision of my life. All right. Anything else? All right. Anyways, guys. That's it. All right. Then go enjoy now. Go enjoy the rest of the evening. Thank you for joining. Catch you guys later. Have a wonderful day ahead and see you in the next session. Take care. Adios, people. Ciao. Konnichiwa. Sayonara. Then arigato. Bye bye. See you all. Take care.